Hey, and welcome back to our Neptune stage. I'm here with Mesut Durukal from Raputo Robotics, who is about ready to tell us all about test automation in an agile way, the 4 pillars specifically. Excited about this. He's coming to us from Tokyo. We were just before this having a good conversation about the horrors of time zone differentials and all the testing on that. But anyway, we're happy to turn it over to him. If you got questions, please post them in the Pine chat. Kind of at the end, we'll collect those up and ask him some questions and at the very end. But with that, Mesut, if you would be so kind.
Yeah, thanks so much, Bill, and hello, everyone. Yeah, as we discussed, I should say actually good morning, good afternoon, and if there is anyone joining like from Far East like me, then maybe good evening or good night. So yeah, I had attended to the Build Staff conferences last year as well. So this is very exciting to be here again this year. And in this session, we are going to talk about, as Bill told, test automation, and we will talk about testing in Agile. So summing these two all together, we will go over the best practices to how to achieve this, how to achieve our goals, to build a quality in our products and in our projects. And yeah, just collect your questions, and share them. Do not hesitate to raise them in the app, Pine app, and I'll try to answer them after the talk. And we can discuss whenever you have any issues or just something to discuss. So this is a brief agenda for the talk. So we will go over 4 basic principles. Of course, when we are talking about test automation or testing in Agile, we can go over lots of different aspects. But what I have tried to do is to collect those fundamentals under 4 pillars, which are the quality mindset, which is closely related to the customer perspective. And then the monitoring activities and the importance of those, collecting some different metrics and performing some monitoring activities. And thirdly, we will go over the importance of robustness in our test automation framework. And finally, the team spirit. Everyone is talking about the team spirit, but why is that so important, and why cannot we achieve individually? We will discuss and we will go over these different aspects to achieve our quality goals and to build a product or to build a process which has a high quality in all aspects. So firstly, yeah, we are talking about different best practices. But what if we don't care about any of those best practices or some fundamentals to follow? And there are some best known anti-patterns. If we don't take them seriously, what may we have in our processes? First of all, the technical debt will increase, right? Because we will have lots of burden in our processes, like we will have lots of refactoring tasks or maintenance tasks, because if we do not build our processes in a healthy way from the beginning, if we don't plan them properly in the first place, then the technical debt will increase in time. And on the other hand, it has some psychological effects as well on, in the team, on the people, on the individuals. It will have some side effects. When the people realize that we are not having any progress to get rid of our problems, then they will lose their faith and they will lose their motivation. So it will have a side effect like a decrease in the motivation and the concentration in the team and in the team members. So when we consider these different aspects to improve our quality and improve our processes, then maybe we can get rid of these problems, and somehow we can achieve different improvements in our processes and in our projects as well. So let's start one by one discussing all those pillars and consider them from different perspectives. First of all, the mindset, the quality mindset. It looks very straightforward, right? Because we are all quality engineers, and of course we have some quality mindset. But sometimes it looks very straightforward, but it is not easy to maintain a high concentration all the time, because sometimes it's very stressful. Sometimes we have a very limited time testing window, and we have a very wide scope to be tested or to be verified. We have lots of test cases to be executed, and they say that we have a very tight deployment time. We have to cover all the requirements and the specifications, and we have a very limited time and we have a very limited resources, of course. So sometimes it is not easy to maintain this concentration and motivation. Sometimes we may have some different tendencies, like everyone is looking into our eyes, everyone is waiting for the quality assurance team's answers and the results. If we will let the release go or if we will block it. So the results from the test executions are very important and everyone is waiting for them. So maybe we may feel under stress. We may tend to complete all of them and set all the results to pass already. But the responsibility which is expected from the quality assurance teams or the which we are supposed to do is to act like a quality gatekeepers. If there is any vulnerability in the product, or if there is any improvement room in the product, then the expected behavior from us is to reveal these kind of improvement points and to share them with the other parties, and in this way to improve the product. So it is important if we are knowing what we are doing, or if we know what we should do, because this was what I just shared is the thing that we should do to reveal the vulnerabilities, all the weaknesses of the product. But if we are doing like only executing the test cases without any exploratory tests or without thinking from the customer perspective, then it is very likely to miss some of the bugs or miss some of the weaknesses in the product. So the awareness is very important from the quality perspective and from the customer perspective, because it is very important. Sometimes we are testing what is implemented, and maybe what is implemented is working properly. But is that what the customer needs? This is the question. So sometimes we don't have to test what is implemented, but what is needed and what is required by the customers or the end users. So it is very important to look from their eyes, because otherwise what we will have some escape bugs. What does an escape bug mean? What does an escape bug mean? It means that if there is a vulnerability in the product, or there is a bug which was not caught by the test activities, but it was reported by the customers or the end users from the production environment, then we categorize this kind of or this type of bugs as escape bugs. And why is that so important to highlight this type of bugs, which are namely the escape bugs? Because it means if we have an escape bug, we will have some extra cost, right? It will be much more difficult to fix them because the running code is already in the production environment, and we will have to apply our fix in the production environment. But if it was already cached in the testing activities, in-house activities, then it would be much more straightforward to apply our fix. We can easily change or modify the flow, and maybe we can update the behaviors in the product. But if it is already in the production environment, then maybe the customer is already knowing all the behaviors, and if we want to modify them, maybe they will be rejecting these kind of changes, and eventually it will be extra cost, because first of all, if they face any issue and bug, they will contact to the support engineers, and then the support engineers will contact to the development team, and there will be an root cause analysis study, and there will be lots of time gap in between the reporting of the bug and the resolution. But otherwise, if we catch it in the early stages, then it will be the early feedback to the development team, and they can immediately resolve all the issues and the potential feature issues. So it is important to be aware what kind of issues customers can have. And in this regards, maybe we should be aware that we are the users, as the testers or the developers, users or who are already using these features a lot of times. But for the end users, it will not be the case. I mean, when we deploy our code, it will be the first time for them to use these features. Maybe it will not be very easy. They will be failing when they are using these features for the first time. We should be aware of this, and not only the functionality, but we should think about the performance as well and the usability as well. Because again, maybe when the end users are trying to use this product for the first time, they will be having some difficulties to find all the functionalities on the interfaces. Like if we have some UIs in our product user interface, they will be having some difficulties to find some fields or to understand what all the elements are standing for. For example, we will have lots of buttons and input fields on the UIs. They should be understandable. And it should be very easy to use, because otherwise they will not like it. If our product is not making life easier for the end users, then it doesn't make sense to have this product for them. So it will be a very easy decision to give up to use this product. So to improve the efficiency, it should be very easy to use. The product should be making life easier for the end users as well. So this is all about the customer perspective and the end user's perspective and the quality awareness and the motivation and the concentration. We should be always aware to reveal the improvement points and the vulnerabilities and the weaknesses in the product. The second pillar that I want to go over is the monitoring activities. It is really important because by means of monitoring activities, we can understand our current situation. I mean, how much progress we already made, or how much more we should do to achieve our goals. We can understand our current position, like we can evaluate our current position, and on the other hand, with the same pace, by doing some analysis, by some future projection, we can do our future plans. We can estimate our future plans in a proper way. So on these two hands, we can make use of these monitoring activities and improve our processes. But what kind of monitoring activities we can perform? What kind of metrics we can track? Actually, there are a lot of dozens of metrics we can track. Like maybe we may have some metrics in terms of durations, time-related metrics we may have, or we may have cost-related metrics, or we may have lots of numbers like the number of test cases we can track in time, if we are improving our coverage or not, or we can track the number of bugs, or we can track maybe the percentage of, for example, the bugs across our test cases. So we can do lots of different monitoring activities over the different metrics. But what should we track? How can we decide which metric we should track? So we may have a decision criteria, like first of all, we have to figure out what our purpose is. If my fundamental purpose is to, let's say, one of my main goals is to reduce the testing duration, because as I told in the beginning, maybe it is very important to have some tight testing windows. So no one knows to have a very loose testing window, right? For example, if a test is running for hours, then it is not easy to maintain this test execution. Normally, it should be, if it is let's say, if it is an API request, then it should be executing in maybe seconds, or at most in a few minutes. So we can reduce the testing window or test execution durations as much as we can. So in this regards, if this is the intention, if this is the motivation, then what we can track is some metrics directly related to this test execution duration. For example, we can query the execution duration for each test case, and we can take the average of all of them. And eventually, we can continue to track this. And whenever we apply some solutions to improve our execution duration, then we can understand if these solutions are improving or contributing to the solution or not. Because let's say this sprint, my average test execution for all test cases was, let's say, 30 seconds. And I made an improvement in my test automation framework, like I get rid of the dummy slips, let's say. And then in the next sprint, I can again do this analysis, and I can sum all the test execution durations and take the average. And then if it is less than 30 seconds, I can understand that my solution contributed into my goal, which was the getting rid of the dummy slips, because maybe I don't need them. They are just waiting. But instead of dummy slips, maybe I can add some polling mechanisms or some retry algorithms. Then it may be kind of smart wait for the expected result or the expected response. So somehow I can continuously do these monitoring activities, and I can understand if my solutions are helping to achieve my goals or not. For example, after I change my code, if the execution duration is not going lower but going higher, then I can understand that maybe something went wrong with my last update. So maybe I can revert, or I can somehow refix, refactor my last update. But an important thing here is to have some environments which is very transparent and visible. What I mean is, for example, let me share a concrete example. On the slide, we can see a test lifecycle, a test case. It is starting with the design stage. First of all, we analyze the requirements and then design our test steps. And then after the test design is finished, I'm sending it to review to a teammate to make the review. And if he or she reviews the test steps and she feels that it is understandable and it is clear, then it means that it is executable, at least manually. If we don't have the automation yet, but we can execute it manually because all the steps are clear and understandable, and there is no obstacle to execute it. So after this point, it is executable, and then I can start my implementation if I'm doing the test automation. So again, first I start with my design in the code, and then when I finish, I raise a PR and send it to review, and someone else reviews in the team. Or maybe we can do some tooling as well to do automatic reviews. Like maybe we can integrate some code quality tools like SonarLint, SonarCube. And in this way, we can already do some code quality checks in the first place, even sending to someone else. In this way, we can reduce the waste of time, and we can improve our code review activities as well. And then finally, after the review is finished, then we merge into our main branch, and we already have the automated code. But you see, in all these stages, we have some different status. Like the test is first starting with the state new or in design, and then it is designed and under review. And then after it is reviewed, then it is in the executable. Why having all this status custom fields is important? Because in this way, we can understand how much time we are spending on each of them. And then what? And then I can understand, for example, in average, how much time I'm spending on reviewing the test cases. Or for example, after I raise my PR, I can understand how much time in general I need to merge this before the raising the PR and merging it, how much time I'm spending generally. I can understand from these kind of analysis studies, and maybe I can have some action items as well. For example, if I realize that I'm having too much time to review the test code, maybe I can encourage the team to make the code reviews in the first place, to not to block the other progresses on different tasks. But if I don't have all these fields, then I cannot understand how much time I'm spending on this, because on all the platforms that we are using, like we may use Jira or Rike or whatever issue tracking tool we are using, mostly they are having some open APIs. So we can add some custom fields, and we can add all the status that we have in our test lifecycle. For example, this is the custom lifecycle for my case, but in any different project or in any different product, there may be some different test lifecycle, and all the relevant status can be added to issue track platforms. And in this way, having all these status in our tools, then it means that we are making our tools very visible about our progress. And then, of course, if we are not keeping tasks or issues up to date, then again, we will not be able to see our progress. But whenever I change my progress practically, then I should represent this on my issue trackment system as well. In this way, it will be transparent, and my progress will be seen over the tool. And then after it is visible and I can see my progress, what I can do is I can automate the monitoring activities as well. Because doing this manually all the time is not easy. For example, what I have to do is every day I have to do my query. I have to open the user interface for my tool, and I have to set the filters, and I have to get the results, and then I have to parse the response on the screen, and I have to understand what the exact information that I'm looking for. But all this can be done with the help of the automated code, some automation scripts. And then additionally, if I have the script, I can do this, perform these monitoring activities periodically. Like I can put on a job, and this job can be triggered on certain time, like every night it can perform the monitoring activities. And in the morning when I go to the office, I will see what was the execution duration already. So automation helps a lot to do these monitoring activities as well. And moreover, what I can do to improve to do this monitoring activity is to generate some charts and graphs. And in this way, it will be much more easier to understand what's going on in our environments. For example, numbers are great. They are holding lots of information and valuable knowledge. But it is not easy to interpret from the only the numbers, from the raw information. But if we transform all this to some charts or monitoring graphs, then it would be much more easier to understand if the trend is going low or high. Or we can set on the graphs, we can set some threshold values or some limits. And if this limit is violated, I can already see from the graph what is going on. For example, if this is representing the load in my environment, and if the load is always increasing in time, then maybe what I can figure out is maybe the tier up code is not working. So the objects are created from the test automation framework, but at the end of the suite, they are not deleted. They are not reverted back. So that's why the load is increasing. I have lots of unneeded objects or entities which were created by the automation framework. These kind of insights I can collect from the monitoring activities, and I can have related action items. I will share a sample application which we have performed in our project, which was the monitoring activities performed on the bugs. We monitored lots of distribution of bugs across different parameters or dimensions. Like, for example, we showed the distribution of bugs across priority levels. For example, what percentage of bugs were in the high priority and what percentage of bugs were in the low priorities. In this way, we were understanding each sprint. We were finding some high priority bugs, or maybe we were mostly concentrating for some low priority aspects of the product. Or we were having like what percentage of the bugs were resolved across the open bugs. So if the gap between the created or raised bugs and the resolved bugs is increasing in time, we were having some action items like maybe it is time to stop the development activities for the new features. But first, let's a little bit reduce the bugs that we have in our product, because the gap is increasing in time, and we are still trying to include some new features, and it will even be more. But if we stop the new feature development activities and first of all eliminate the high priority bugs, then it would be much more straightforward to plan the next release activities. So these kind of insights were really helpful to plan our release activities and to understand our current situation. We are already in what percentage of the goals are already achieved, or what else we should do furthermore to achieve our goals. These kind of insights were collected by means of monitoring activities, and they were helping us to make our decisions easily. And now I want to go over the third pillar. After the quality mindset and the monitoring activities, The third one for me is the robustness of the test automation framework. What does robustness mean? It means actually the reliability. It is directly related to the reliability of our test executions. For example, if my test case is reporting a bug or reporting a failure, then normally I should understand that something is wrong in the product because my test case is failing. It means the expected result is not there. The actual result is not meeting with the expected result. That's why, or normally that should be the reason why my test case is failing. But if that is not the case, I mean, if my test case is reporting a failure, but if the feature is working properly, it means that it is not a real bug. Normally, there is not a bug in the product because it is working properly, but somehow my test case is failing. It means it is a false alarm. So it means that my execution is not reliable. I cannot trust to the execution results coming from my automation framework or my execution platform. So this results or causes some extra maintenance efforts and some extra analysis efforts because I have to each time I have to understand if it is a real bug or a false alarm. So if somehow my test framework or execution platform is not robust and is not reliable, then I have to improve this situation and I have to get rid of this flackiness. So as I told, if there is a failure report which is not representing a real bug, it means the false alarm. And on the other hand, maybe the test case is not reporting any failure when there is a vulnerability in the bug. So this case is meaning the silent horror case in which normally we have a vulnerability in the bug, but my test framework is not capable of finding this vulnerability. So it doesn't report any failure, but normally there is a weakness in the bug. So this is the silent horror case. These two situations are the unexpected situations. I mean, normally the test framework was supposed to catch these kind of issues, but if it is not, then it means that these are the improvement rooms for us. And there may be lots of reasons for these unexpected situations, and we mainly call these kind of situations as test smells. Like the code smells we may have in the product, similarly, we may have some test smells, which is the weakly designed test code which may result in these kind of unexpected situations. Like if we have some very well-known anti-patterns in the test automation framework, and or if we have any other issues in the test code, then we may have some test smells. And what kind of test smells we may have in our automation framework? Actually, if you make a survey about the test smells, you will find lots of categories of test smells, maybe more than 100 categories of test smells exist in the literature. So, but I will not, of course, go over all of them. But the very well-known one is the flaky tests, which means one-time passing and one-time failing. For example, today the execution, when I checked the execution, it was pass, but in the next execution, it has failed. And then maybe if I retest, if I execute again, maybe it will be pass again. So it is flaky. So it may be stemming from lots of different reasons. So most probably it is a timing issue. Like, for example, if the system is under stress or there is a lot of load, then maybe the response is not there in the expected time, or somehow the response is coming late. So if I'm checking for the response in a certain time, like if I don't have a smart wait for the response, then for example, if I'm waiting for 2 seconds and then check the response, maybe it is not there. So this means my wait for the response is an asynchronous wait. But I have to replace these kind of things, these kind of waits with the polling mechanisms or retry algorithms. So there may be lots of different kind of test smells in the automation framework, and there may be lots of root causes underlying in the framework for these kind of issues. So what we can do is, first of all, we can list all the issues that we have. For example, we have lots of maintenance efforts. Every day, I have to go over the failures and have to understand if this is a real failure or a false alarm, or if I have to always refactor my code. What can be the reason for that? Maybe I have lots of code duplication in my framework. So whenever something is changed in the product, accordingly, the test code should be updated. But if I have lots of duplications, then I will have a lot of maintenance effort. But if I already reduce the code duplication, like I can collect all these kind of commonly used code blocks into some helper classes and call only the functions or the methods from different use points, then I would refactor only the relevant function, which is in the helper method. So the thing that I can do is to list all the problems and then relate this to the underlying root causes. And then one by one, I may try to resolve all these kind of root causes and eventually get rid of all the testimonials in our automation framework. So what we did in our project is we similarly, we listed all the problems and then we applied some solutions. And after each of them, we did a before and after comparison, like a benchmarking. For example, in this graph, we can see that without having a solution, we had a number of failures in a certain number of executions. Like, for example, in 20 executions, we had maybe 4 or 5 flaky results. But after applying the solution, we had only 1. And maybe that was a real bug, not a false alarm. So with these kind of benchmarking studies, we were understanding if the fix that we applied is the solution that we need, or if we see that it doesn't work, it doesn't change a lot in the execution, then we were trying something else. But eventually, summing up all the code quality issue in the automation framework, I mean the importance of the quality in our test automation framework, the result is the consequences, we need some strong quality gates. But really strong quality gates, I mean, we may generate a checklist before merging all the changes or updates to the production environment. We should block the vulnerabilities or the threats in the first place. Because otherwise, it means that we are letting the potential risks to go into production environment, and there will be the threats or the risks for the future activities. So now the fourth pillar, which is the team spirit and the importance of performing as a real team instead of just individual performance, to act as a whole team and to embrace a holistic approach. Let's discuss why this is important. Because actually, quality is not something that we can achieve individually. We can do that as a real team work, right? Because as we all know, we are now running some agile approaches, like maybe we are having sprints, and in each sprint or in each cycle, we are having the minimum viable product, which means at the end of each cycle, we are having some potential shippable product. But to be able to do this in a very limited time, in 1 week, in 2 weeks, whatever, in a very short time, to be able to achieve this, we should be in a full sync with all the parties. Like, for example, if the development team is doing something, but if quality team is not aware what the development team is doing, then we cannot start our quality assurance activities in the meantime. But if they inform us about all the activities which is performed in the team, in the dev team, then we would know all the developed features or the specifications. And before waiting the product, the running code, we can already start our test preparations. Like we can already design our test cases to gain some time in advance. Or we can prepare our test automation scripts as well. And we can think about lots of different coverage scenarios. Because it is very important to cover lots of different corner cases. We can already design our test cases and test scenarios. And apart from that, having a good test strategy is really important. Like, for example, if we don't have lots of different priority levels, then we would not be able to do the prioritization. And why prioritization is important? Because infinite testing is not possible. We have lots of different test scenarios and we have a very limited time. So most probably we would need to select some of them to execute in a very limited time. So what should be the best cases to execute? Of course, which are the most important ones, which are the most critical ones. So how can we understand which are the most critical? Because if we already mark them with different priority levels, because normally we can do this study considering lots of different aspects. For example, to decide about the priority, we can evaluate the visibility of the feature or the test case, or how what kind of impacts these kind of test cases or features have in the production environment. We can evaluate the different aspects and we can come up with different priority levels. And eventually, we can generate our suites according to these priority levels. And similarly, if we are not discriminating different testing levels, then we would not be able to manage our test executions and release activities. For example, normally, as we all know, the very best practice is to have the test pyramid, like have the most coverage in the lower levels, like unit level, and have a smaller subset in the user acceptance level. But if we are not doing this, if we are trying to cover most of the cases in the user acceptance level, then we will not have too much time to do that. So we should build our strategy in a proper way. And for this, of course, we should be working in a harmony with all the parties. The quality team should be in a close relationship with the product owner or the product team or the development team as well. They should know what the other teams are doing currently and about all the progress on different tasks and on different features. Because otherwise, if they are not informing each other, then they will be having some issues and conflicts, and eventually it will not be the way in which we are achieving our goals. Because last but not least, we are all on the same boat, and the quality is something that we achieve as a holistic approach, not by individual efforts. So I'm summing up all we discussed in this session. Those were the 4 fundamental pillars to achieve a good, successful agile test automation process, which were first of all the mindset, quality mindset, which was directly related to the customer perspective and seeing the product from their eyes. And secondly, we discussed the monitoring activities. From the monitoring activities, we were able to understand our current progress, like the current evaluation, and to be able to do the feature estimation as well, on the other hand. And we discussed about the robustness and the reliability of the test automation framework. And finally, we discussed the team spirit and the holistic approach and the importance of this team spirit. So these were the 4 fundamental pillars to successfully perform an agile test automation process. So thanks a lot for listening to me. And again, please, if you have any question or if you have any suggestion, just do not hesitate to raise them, and I'll try to answer if I can.
Thank you so much for that talk. And I believe we have a bit of a break here before our next session for folks, coffee break. Lunch break, that's right, it's a lunch break. Yep. As I've been doing time zones in my head and failing at it as per usual. And I'll see you guys and gals back for that. And thank you so much again, Mesut, for that great talk.
Thanks a lot. It was my pleasure.